So I'm gonna attempt to capture the difference in temperature as the pressure inside the recovery bottle goes up. You're gonna see the temperature change. You already can see the hot temperature of the motor and the hot air blowing out of the vacuum pump right there, because I was drawing vacuum on all the lines to recover all the lines and clean them out prior to recovery. So everything is recovered and vacuumed out, cleaned, purged. The line has liquid going up to this location right there. And let's take the temperature of the bottle right at the center. So I'm right at where the brass goes in. If you look at the word CEN, center, that's about where the brass is. And that is 70 degrees. The minimum temperature it sees on my recovery bottle is 68 degrees. And if we look at the lines, see the refrigerant lines laying down there? Let's look at their temperatures, everything. Nothing's really cold there. If you look at max, minimum, and center, we're between 87 degrees and 67 degrees down in that area. If we come down here, let's see if we can see the lines from below. Yeah, we can. If we go right about here at the refrigerant lines, and I aim at the refrigerant lines right there, you can see our temperatures, min, max, center are, what is that, 78, 7, I can't really see, sorry guys, I'm bending way down here and squinting my eyes. 70s, somewhere in the 70s, but we'll come back to that. So let's start this up. There we go, we are now recovering. Let's look at we're going to look at right where the refrigerant goes in at. We're going to see if we get a temperature change difference going on here. Let's see. And I'm trying to get the glare out of your eyes. There we go. I'm getting center. It's going to take a little while. Am I going? Yeah, I'm going. So the maximum temperature is now 80, 81, and you can see it going up by tenths of degrees Fahrenheit, 82. So let's come back over here and look at our service footage. You're starting to see some black develop on the lines inside there. You see the lines? That's there. You can see that liquid line going up, turning really black. You see that black line, that minimum temperature? What's that say? 38 degrees? Because that's where the refrigerant is being pulled from on the vapor side. And my center, where's my center at? I can't even read anymore. There we go. Center is at 40 some degrees, 47, I can't really see. Let's come up here. Let's see what the temperatures look like down in this area. Oh, we can see some blackness going on there. You see that right there, minimum temperature, 32 degrees. That was the liquid that was sitting and that is being pulled up in the bottom of that suction line. Now you always think of suction lines being vapor, but when you turn off the vehicle and let it sit all the night, overnight, all the liquid goes to the lowest point. And you can see this goes up, and then over here it goes up again, and that's the lowest point. So when you start lowering the pressure right here, the oil in the refrigerant in that lower line turn into like a foam, and it actually travels up the line, and you can sometimes remove a little oil with that at the same time. So now I'm going to open up the high side too, because I'm down to almost nothing, and we are going to pull a little more refrigerant out. As you can see, we're up to 101 psi now inside this tank, so we should definitely see a temperature difference. So let's go back here and let's look down here again. You see our minimum temperature, 26 degrees Fahrenheit. What's the compressor doing? You can see the lines coming from the compressor. You see the black lines right there? They're at 36 degrees. And you can see the temperature out here. This vehicle has been sitting overnight, so it's between 71 and 73 degrees. That is the temperature of this material, plastic, that's been sitting overnight, and it's almost a flat matte black. And so we know the temperatures are accurate. So let's go look at our tank. It's glowing really good now compared to the cold concrete. Now look at our tank. So we got 80 degrees, 87, 88 degrees. 68. 68 must be reading the floor. Let's see what the floor is. So the floor is the background around the tank. And you see 68 degrees, 71, 70, that's the floor. But if we come and you see that, you see this little shadow right here where my foot is? A little bit of, see that shadow? Let's follow that. So what that is it's the hot air. So the hot air is blowing over here. There's a slight temperature difference developing right here that this can pick up from the hot air warming the surface. And if we look at it closer, we now see that there's 141 degrees maximum temperature coming out of there. And that's the fan motor and the motor from the vacuum pump. We come over here, you could see the hot condenser inside the AC. And you see the fins in there? So that's the condenser you can see back there. And pressure temperature relationship, this is R134. So you actually see the lines are getting hot. You can see the suction line is cold. This line right here, you see how it's black? Because this is under vacuum. -20, so this is cold refrigerant traveling in there. But you see the other bright line right here? That one's hot because that's the discharge line, which is at 96 psi. Oh, I'm vibrating. That's the problem with vibration when you don't lay your lines correctly. They will, the vibration will make your lines unscrew, and you either can purge your refrigerant to the atmosphere, or if you have it wrong, you can suck in air. It'll loosen up right here and suck in a bunch of air, pressurize your tank up to 500 psi, and or force something, and either your blow off will go off or your high pressure safety will cut out and shut off your compressor if this screws by the vibration, unscrews and sucks in air while you're not monitoring it. And we can see it's nice and bright now. Let's pull back. So now you got you have a black background. What is the cold cement? We know that's 60 some degrees. And if you look at the minimum, the maximum, it is picking up the temperature of the concrete, 67 degrees. The maximum is 84 somewhere in there. Let's get way in there and see 86. So that's because of heat of compression, because the cylinders of the piston pump inside here draws it in under a vacuum, compresses it, raises its pressure, it raises its temperature, and then pumps up the tank. Let's see what we're doing down here now. You can see the blackness on the lines in there, how cold they are. There you go. And what are our minimum and maximum? Let's see if I can make this thing focus. Come on. Sorry for the waving hand here. Well, you guys could read that. I can't because I'm upside down with my head turned because I'm bending over to do this under here. And you can see we're at a negative vacuum right now, but there's still a lot of refrigerant in the system. If we look at the compressor itself, the compressor itself is center. Center says it's 78 degrees, but that's a cold line down there. 47, 33, 33 degrees on that cold line down there. All right, guys, that's enough for your pressure temperature relationship under drawing refrigerant under vacuum. But let's not use the word vacuum. Lowering the pressure on the refrigerant lowers the temperature. Raising the pressure of the refrigerant raises the temperature. Go to a PT chart for the refrigerant you want to find out on, and you can look that up.